Hello, welcome to this video of OpenMathAI. OpenMathAI is a no-code platform from Vista One Labs. This platform is a no-code platform for all your uh, AI modeling purposes. You can start with the data and with very nice um, wizard type of workflow, you can get from your data to an explainable AI model. And not only stop there, but also generate code if you wanted to for various and exportable cases. We'll see more as we proceed to the video today. Let's get started. As you can see, there is a splash screen that explains what we offer. There is also a lot of blueprints, as we call it, especially for specific domains. We cover about 19 sectors, 175 blueprints. The idea of the blueprints is you can start with an already set up example from where you can change your data and probably customize it and get to finish lines as fast as possible. Of course, you can also start with a very plain scratch model from the beginning as well. What's special about OpenMathAI is its proprietary discovery engine. OpenMathAI tries to explain the AI models using simple math wherever possible. There are certain models that can be explained, certain models cannot be, which can still be a black box. But the majority of the models that are supported in OpenMathAI are white box. So it's human readable, backed by physics, and then ready for mission critical applications if you wanted to export them. OpenMathAI also makes it very easy to go from your working AI model to the edge platform. We'll see that more when we cover the export options. Be it a PLC, be it a desktop, be it cloud, you can easily take your machine learning models that were trained. And of course, not to forget, you can take the AI models and put them back in your digital twins and have both the system model and AI model together and see how they work well. As you are aware, the Vista One Lab also offers a system modeling platform called Twin Simulate. Let's get going with the workspace and see how an example works. This is the screen on the launch screen of OpenMathAI. As you can see, there are a lot of blueprints that are available, and one can start with different kinds of models or different kinds of domains, and then get going from there. Went through something interesting today just to show the power of how you can get from data to the final outcome. Let's start with a new project. I'm going to create a new project and call it my first project. As you would expect with any machine learning exercise, you have to import your data. There's a lot of importable data formats that are available. You can start with CSV, Excel, JSON, Packet files, Feather, Pickle, and so on and so forth. And if you don't find a data, we also have APIs to add your own data formats as well. Let's browse and look at one of those example data sets and go from there. Let's see. Let's take a very generic example of a house price prediction based on various different parameters. As you can see, the import of the data loads the data, gives you a preview. And the data does have a lot of columns. On the last column, you have the pricing in the USD, and there are also variables that are affecting this final pricing. The tool also allows you to look for duplicates, look for missing values, and if need be, you can correct them as well with this signal intelligence and auto polishing features. Let's go ahead and continue to choose the columns that are necessary for machine learning and see how it's done. Let's continue. Now, in this particular signal configuration doc, you have various signals that are available, and then as a machine learning exercise, you essentially want to see, pick and choose what inputs and variables that you want to pick, and then what do you want to predict. At this point, we have the data that's available in the signal pool. OpenMathAI allows you to do two kinds of signal selections. One is you can also do what we call the smart suggest, wherein the OpenMathAI looks at the data and looks at how these variables are connected to each other, how they are influencing each other, and tries to do a smart suggestion on what could be your inputs and targets. Or you could also, drag and drop the available variables into the inputs in the targets category. In this case, we are doing static model, and just to give the overview simple. But let's go ahead and try the smart suggest feature. OpenMathAI does pick some of the inputs from the available signal pool and targets. At this point in time, we are here. We're all set to go and train a machine learning model. Let's go and proceed. As you can see, there's a lot of models that are available in the platform. OpenMathAI also tries to do a suggestion on what kind of models could be useful for this particular case, looking at the data. It's found that in this case, models that are recommended are either to use linear or a lasso or edge regression, given the data points and the quality of data that it accesses. Now let's pick a couple of them to see how it all comes together. Let's pick linear and edge regression together and proceed to training. So what you can see is you have two models that you want to train against your particular data. And then you can start training all of them, even set up parameters if you wanted to. Let's leave it at default for now. Once you have that, please note that you also have pre-processing that is set up so that you can scale the data as it's needed for final deployment as well. So once I start the training, because the data points were quite less, it went through train both the networks very fast, and then gives you this window of what kind of model it looked at and what's kind of the accuracy levels here. In this point, in this particular case, the champion model happens to be the linear regression. If you want to look at the model and how it performed and how it actually looks like behind the scenes in terms of math, you can go and look at what is called view math code. And this, I think, is very unique when it comes to OpenMathAI. You can look at the code view as well as the math view. The code view gives you exactly the C code, and the math view gives you the relationship between the variables and the equation altogether. As simple as that. You can also select those models, export them, and in this case, we select C code and hit and deploy. So as you can see, you can generate from both those models very quickly. And at the end of the code generation process, you also get a nice output of both these models. Each of these models is exported along with a nice report, which walks you through how the model was generated, what's kind of the scores, how the model is performing with respect to the data that is presented with respect to the ground truth, what kind of functions exist, and how do you compile them. So for example, in this case, it tells you that there is a make file that's available. You can compile it, and what kind of files are required to kind of create the executable. Let's try to compile this code. So I open up a command prompt. I have GCC installed on my machine, so I do a make. As you can see, the executable gets generated. You can either test the executables standalone like this, wherein a test input is provided and an output is produced, or you can also give it a CSV, as you can see here. And this should produce predictions. It tells you what's the predictions here. So that's pretty much it. It's quite simple to start with a model, generate code, and export it, and finally use it, all with a no-code platform. And that's what OpenMathAI brings in. Thank you for watching this video. There are more videos coming with more details and different machine learning interesting topics. Stay tuned. Thank you.